Hi guys, hope you're having a good week. We're going to start chapter 11, which is about the mole. Now this is some math, so you will need a calculator, but it is not too bad. So don't freak out, just practice, and we'll do some practice when I get back. Remember, when you're doing these, you can pause them and take notes, and then come back and watch them if you need to later on. So section 1 is about measuring matter. So if we think about when we measure things, think about how many eggs are in a carton. Okay, when you think about how many eggs are in a carton, how many eggs are there? Well, we know that there are 12. Okay, we also know that eggs or shoes come in pairs. Okay. A ream of paper is what we would get out of the office to put here. A ream is like, I think, 100. A gross is, I don't know, we'd have to look it up. But they all have measurements for how much these things represent. A ream is actually 500, and a gross is 144. If you look at page 309, they kind of describe some of those. But that's kind of how, when we look at a mole, how we are going to look at things. So when we count particles, chemists need an easy way, I should say way, to accurately count the number of atoms or molecules that we have. Okay. Or formula units, because these things are so very small that it's very impossible to count, and the number that you would get to count these atoms would be so big. So we need something that's going to be easy for us to understand. So scientists have created what we call the mole. We have the mole, which is an SI base unit used to measure the amount of a substance. So if you hear someone talking about a mole, it is a standard unit that's going to measure the amount of a substance. Well, 1 mole is actually the amount of atoms in 12 grams of carbon, which that's not too big of a deal for us. We don't really need to look at that. But what they've done is, this is a number that you're going to need to memorize right here. 6.02 times 10 to the 23rd particles. This can be atoms, this can be molecules, formula units, electrons, but this is the number of particles in 1 mole. This is called Avogadro's number. So if we're ever talking about how many particles, how many pieces, how many atoms there are in a mole, it's going to be 6.02 times 10 to the 23rd. That means I'm going to move the decimal 23 places. That's going to be 21 more zeros behind this. Okay? That is a lot of atoms. Well, atoms are so small to get to this amount. So this is Avogadro's number. This is something that you're going to have to remember. 6.02 times 10 to the 23rd particles or atoms or molecules. Now I'll explain that here in just a second. So let's go back. When we talk about 2 dozen roses, Valentine's Day is coming up, or it actually just passed for you guys, I guess, last week. If I said that I got 2 dozen roses for Valentine's Day, I was really lucky. They spent lots of money. How many roses is that? Well, you can do that in your head. I know that 1 dozen is 12 roses. So I would need to create a fraction. This is kind of hard to write with. But I would create a fraction. If I always start with the number that I have, 2 dozen, and I want to know how many roses that is. So I want to multiply that by my conversion factor. I can't even spell with this mouse. 2 dozen. How many roses? Well, 12 roses is going to go on the top. In 1 dozen. So that dozens cross out. And I am left with 24 roses. You guys did that in your head, but this is how you did it. And I want you to remember, we need to go through this process, because as this gets more difficult, this process is going to be very important. Remember, we've used this when we convert some things from kilograms to grams or other things, but it's very important that we use this conversion factor, this process that we go through, okay? Dimension analysis. You've used it in math before too. So We need, when we convert from moles to particles, we must use those conversion factors. So we need to convert. To do that, we want to go from moles to particles. I'm going to start with moles, and I want to figure out how many particles or atoms there are. My conversion factor that I always need to use is right here. 6.02 times 10 to the 23rd particles per 1 mole. Now remember, we can flip this if we need to, depending on what we start with. But if I start with moles, and I want to get rid of moles, moles needs to go on the bottom, and particles, since that's what I want, needs to stay on the top. So let's figure out if I want to calculate the number of molecules in 3.5 moles of sucrose. I always start with what they gave me. They gave me 3.5 moles of sucrose, so I'm going to start with what they give me right here. Okay, it stands alone by itself. Since I have moles and I don't want moles, moles goes on the bottom. And 6.02 times 10 to the 23rd molecules goes on the top, which is what I want. Moles cross out, I'm left with molecules, which is what I want. And I just multiply straight across. 3.5 times 6.02 times 10 to the 23rd, and I'm left with 2.11 times 10 to the 24th. Now, this is something that you're going to have to use your calculators and figure out how this works. Okay, so you're going to have to test out your calculators to figure out the best way to make this work. So if I use one that I have right now, I put 3.5 times 6.02. I like to use the, you can use the caret, which is the little arrow button. So you could go 6.02 times 10 caret 23, and that would give you your answer, and it would already be in times 10 to the 23rd. Or, in these calculators, you can do 3.5 times 6.02. You can do, I think there is a, yes, there is a 10x. You can do second log, which would be the 10x, and then just put the 23 in parentheses and hit enter, and it will give that to you too. So experiment with these calculators and make sure you get the right answer, because that's going to be half of the battle in this section, is just plugging it into your calculator right. All right, the next one, the last one, is when for this section is going to be converting particles into moles. So if I'm going to go the opposite way. I'm going to start with particles and I'm going to go to moles. So this time I'm going to use the inverse. The same factor, Avogadro's number, is my conversion factor, but now I'm going to use the inverse, which means I'm going to flip it over. So now my conversion factor is 1 mole per 6.02 times 10 to the 23rd. The only thing I'm memorizing is this right here, but now I've flipped it. If I start with particles, then I want particles on the bottom to give me moles. So let's say I start with 2.11 times 10 to the 24th molecules. I don't want molecules, so molecules is going to go on the bottom, and 6.02 always goes with that. They stay together. So 1 mole would be on the top, so I just punch that into my calculator again. Now, one thing that you need to remember is when I'm dividing, I have to use parentheses. I have to use parentheses, otherwise you will end up getting a number that's like 10 to the 47th or something. It won't come out right. You must use parentheses. So again, test out the calculator, try it out, and you need to end up with this answer, 3.50 moles. Okay, so let's do some practice. That's the end of the notes basically for this section, but let's do some practice before you have your assignment. Okay, so on page 311, work this one out. 2.50 moles of zinc. Okay, remember we always start with what we're given, 2.50 moles. Now I want to know, in these ones, we want to know how many atoms. I want to go from moles to atoms. Well, I have moles, so moles needs to go on the bottom. And atoms is going to go on the top. My conversion factor is 6.02 times 10 to the 23rd. atoms. I multiply straight across, my moles cross out, I'm left with atoms, and you should end up with this number. Okay? I want you to do 2 and 3. These aren't that bad, but if you don't practice, you won't get them. Okay? So I want you to work, when this is done, I want you to work 2 and 3 in your notes and check your answers with Mrs. Gibson. She can check to tell you whether you got the answer right. Okay? On page 311. And I want you to practice those. Okay? You must work some of them or you won't get it. Okay? We'll do some more when we get back. All right. The next one on page 312 is the inverse, remember. I'm giving 5.75 times 10 to the 24th, and I want to go to moles. So I'm going to start with what they give me always, 5.75 times 10 to the 24th atoms. And atoms is what they give us, but I don't want atoms, so atoms is going to go on the bottom, so I can get rid of it. So that means 1 mole will go on the top. But what goes with that? 6.02 times 10 to the 23rd. Okay, so atoms crosses out. I basically multiply, which would mean I take 5.75 times 10 to the 24th times 1 divided by, and make sure you use your parentheses, and you should end up with 9.55 moles. Again, do the rest of number 4. So number 4, B through D, and check your answers. Okay, you can also go to the board if you want and work those out and have Mrs. Gibson check those with you. I will maybe make a note that you should go to the board. That usually works better. All right, so you can flip through your section check, see if you get those right. I'll flip through those. And then you have an assignment. Mrs. Gibson can give that to you, but it is page 312, 5 through 10. So section questions on page 312. Have a good day, and we'll talk to you later.